Our next question is for each of the following parabolas to find the zeros, to find the vertex, then to graph the parabola. And we find it's often convenient to do things in that exact order. This is kind of a way of putting together a lot that we've learned in this section. So, we'll start with the first question, our parabola. Y equals 2x squared plus 4x minus 6. Well, we begin in step 1 by finding the zeros. So we let y equal 0 and we get that 0 is 2x squared plus 4x minus 6, which means if we can common factor out the 2, we'll be left with x squared plus 2x minus 3. And then we'll have 2 times a factor of x plus 3 times a factor of x minus 1. Now since 0 is equal to these three factors multiplied by each other, then one of these three factors has to equal 0. Since 2 can't equal 0, then x plus 3 equals 0, or x minus 1 equals 0. So if x plus 3 equals 0, then x is negative 3, and if x minus 1 is 0, then x is 1. Well, we found our zeros, and so now we can find our axis of symmetry relatively simply. We find the midway point between those two numbers. Well, negative 3 plus 1 over 2 is equal to negative 2 over 2, which is equal to negative 1. So we have an axis of symmetry at x equals negative 1. Well, that's the x value of our vertex. How do we find the y value of the vertex? Well, we sub in the x value to any valid version of the parabola formula. Now, the original equation was y equals 2x squared plus 4x minus 6, but we see through factoring that y also equals 2 times x plus 3 times x minus 1. So what we're going to do is we're going to substitute x equals negative 1 into these two numbers and try to discover what y will equal in that case. So when we do so, we get y equal 2 times negative 1 plus 3 times negative 1 minus 1. That becomes 2 times 2 times negative 2, which is negative 8. So we have a vertex at negative 1, negative 8. So we certainly have a lot of information now. A vertex at negative 1, negative 8. Of course, our axis of symmetry at x equals negative 1, and zeros at x equals negative 3 and x equals 1. Well, I've taken the liberty of drawing the first graph. Using everything that we know, we see our parabola looks like this. We graph our vertex at negative 1, negative 8, and our zeros at x equals negative 3 and x equals 1. Alright, well, let's move on to the next question. The next question says y equals negative 3x squared minus 6x. So what we do is we common factor. After letting y equals 0, we common factor out negative 3x. And inside the bracket we have x plus 2. Well, this means that either negative 3x equals 0 when there's a 0, or x plus 2 equals 0 when there's a 0. Which means the zeros are located at x equals 0 and x equals negative 2. Alright, well those are going to be our x-intercepts, but let's find our axis of symmetry. We add the two numbers and divide by 2, and we get an axis of symmetry just like the last question at x equals negative 1. Now before you think that's always going to happen, it's not always going to happen. Then we move on to sub in x equals negative 1 to the equation. So y will equal negative 3 times negative 1 times negative 1 plus 2, which is negative 3 times negative 1 times 1, which is positive 3. So we're going to have a vertex this time at negative 1, comma 3. Well, let's get out a sheet of graph paper and summarize everything that we know. We know that we have zeros at x equals 0 and x equals negative 2. So we've located those 2 points on the graph. And we know that we have a vertex at negative 1, comma 3. So we've located that point on the graph as well. And now our job is to draw the best parabola we can going through those points. And it looks something like that. Pretty accurate, really. And then we get down to our last question, which is y equals negative x squared minus 8x minus 15. Well, we factor negative 1 out from each term. We get that 0 is equal to negative 1 times x squared plus 8x plus 15. then we can factor the bracket and get x plus 5 times x plus 3. Now, we know that in order for there to be an x-intercept or a 0, that 0 has to equal this factor of -1 times this factor times this factor. Since -1 never equals 0, that means either x plus 5 equals 0 or x plus 3 equals 0. So we set x plus 5 equal to 0 or x plus 3 equal to 0, and we get that x equals -5 or x equals -3. Alright, well, that means that our axis of symmetry is going to be at the sum of these two zeros divided by 2, which will be at x equals -4. If we'd like to know the vertex, then we simply sub x equals -4 into one of the parabola equations. Well, we could use -x squared minus 8x minus 15, but I prefer to use that y equals negative, bracket x plus 5, bracket x plus 3. When we sub -4 into this equation, we get negative times -4 plus 5 times -4 plus 3. Well, that's like saying -1 times 1 times -1, which is positive 1. So our vertex is at x equals -4 and y equals positive 1. Alright, well, we're now going to summarize all this on a sheet of graph paper. Y equals -x squared minus 8x minus 15 is a parabola with zeros at -5 and -3, and a vertex at -4, 1. And if we now want to graph this parabola, we simply extend out the branches of the parabola accordingly.